Hi guys, welcome back to another Mr. Cuban lecture. Today I'm going to talk about Z. Now, Z in chemistry has kind of two meanings, and this is where you need to be a little bit careful and go under which curriculum you're talking about. So when you first talk about chemistry and you learn about Z, it literally just means, and I'm only going to do this once, it literally just refers to the atomic number. Okay, so when you look at a periodic table, it can be any periodic table, I got one here, it's from somewhere. Z is just going to equal number 1 for hydrogen. It's going to equal number 2 for helium, number 3 for lithium, and so on and so forth, all right? But then there's another Z, and this other Z is actually much, much more important. So the other Z tells you properties of the atom that helps you to understand what it does in a reaction. The other Z is called the effective nuclear charge. Okay, so the other Z refers to the charge that an electron on the outside of the atom feels from the nucleus. Okay, and there's really at least two different ways to calculate Z in this case. So if I were to take an atom, and let's say we'll look at sodium, okay? Sodium has 11 protons, right? So I'm going to use the Bohr model for this. And the reason I'm going to use the Bohr model for this is because it works. So if you've studied a bunch of chemistry, you've learned that the Bohr model is wrong. But it actually works for a lot of things, and Z is one of them. So there's 11 protons. And in the first shell in the Bohr model, we have 2 electrons. Right? So electron 1 and electron 2. And you know that electrons don't like other electrons. So what happens is these electrons do kind of push on each other, but not much. And actually, for the first way to calculate Z, you assume they don't push on each other at all. Because we're going to say that this positive charge pulls on these electrons the exact same, and neither one of them is really able to repel the other. And effectively, that is kind of what happens. All right. Then we're going to look at the second shell. Okay, now the second shell for sodium is going to have 8 electrons. 2, 1, 4, 5, 6, 7, 8. Now what's happening here is these electrons on the inside push out these outer electrons because they have a negative charge, and a negative charge repels a negative charge. But this positive charge, this 11 positive that's here in the middle, is going to be sucking in on those electrons, and it pulls in these 8 pretty well because just 2 electrons isn't that much repulsion. Sorry. Now, the outer shell, this is that lonely kid in the corner of the cafeteria on his own, needs a friend, all right? And what he does, he actually maybe goes to another cafeteria to find a friend later on in a reaction. This is in an ionic bond. This electron completely leaves sodium and it becomes sodium positive. And this electron finds happiness somewhere else, all right? But what's happening here is these 2 electrons and these 8 electrons are pushing this electron. So this Z, the easy way to calculate this is to say 11, because that's the number of protons. So we have the number of protons, and it's going to be minus, and then we're going to say core electrons. So we're going to say that these electrons and these electrons push on that one the exact same amount. So there's going to be 10 core electrons, so it's going to be minus core electrons. Okay, and it's going to equal 1. And so Z, this Z, the other Z, and sometimes it's Z star, and they might use a little bit of notification, depends on the textbook that your teacher is using, will tell you that it's got 1, okay? Super easy. There's another set of rules, okay? Slater's rules. And what they say is that electrons in the same shell do repel electrons. Now, sodium doesn't have, so with Slater's rules, it says an electron in the same shell repels at 0.35 of an electron. So instead of saying this electron pushes that electron with the same force that this proton pulls. So let's say one proton pulls in this electron and this electron pushes that electron the same, so it would be 1, but it's saying 0.35 in the same shell. So this electron pushes that one with 0.35. And in the second shell in, these electrons push that electron with the electrons push with a 0.85 strength. So it's not 1, it's a 0.85. So these electrons are pushing that one, but not as strongly as these ones. These ones get a total value of 1. So you'd say all other core electrons, okay, all other core electrons push with a strength of 1.00. So you'd say these electrons push that electron with the same strength that these protons pull on that one. And if you do this math, you end up with 11 minus, now there's no electron in the same shell, so it'll be minus 0. All right, so it's going to be 0 times 0.35, okay? And then it's going to be minus, and this is where I might actually want to get a calculator out here in a second, minus 8 times 0.85, and then you minus 2 times 1. All right, so if I take this 0.85 times 8, 8 times 5 is 40, carry the 40 times 8 is 64, 68, 6, 8, and then you have 2, so 6.80 plus 2, so it's going to be 11 minus 8.80, carry the 1, 2, 2.20 equals this Z. All right, and if you run through all of the first row elements, okay, that is these elements that are here, you can see what the pattern is on your own, and maybe you'll see if there's a different Z for each level, okay? In the next video, I'm going to talk about how Z can be useful to determine the ionization energy. Now, the energy is the amount of energy that it takes to remove this one electron, okay? So let's say this electron is the poor kid eating in the corner. Maybe he doesn't have friends at his current school, and so he wants to go to another school. It's how much energy does that take, and how for them to become happy and move on to there. So this was my lecture on Z, which is called sometimes just the atomic number, or quite literally the atomic number is equal to the nuclear charge. If you notice that, it's also sometimes called the effective nuclear charge. So you have to really be careful how you're talking to this with your professor when you do talk to them about Z. All right, have a good day. Bye.